Okay, ladies and gentlemen of Algebra 2, this is Mr. Heeren once again talking to you about polynomial functions. And what you're trying to do is look at a polynomial function, more specifically looking at the graph of a polynomial function and using the degree and end behavior. Tell me a little something about the graph and then tell me how that relates to the function. Now, there's a couple things that you can keep in mind while doing but first, let's take a look. You have 3r squared, 3r plus 1. Figure out what happens when r is 4 and r is 12. So, if I just substitute in 4 and I substitute in 12, what they're trying to do is figure out what's going on. So when I evaluate this, I should be able to get one number. So here I should get 37. And over here, 12 squared times 3 minus 36 plus 1 is going to be 397. So there's my two answers. Now, that's how many hexagons there are when you go out each ring in a honeycomb. So now, what is it with anything? Well, here's what we're talking about. We're talking about polynomials of one variable. So there's no variables in the denominator. You're talking about the degree and the leading coefficient. Degree is the highest exponent, basically. It's the largest degree of a monomial in the polynomial. So basically, you are looking at the exponent. That's what you're looking at. And leading coefficient is an actual number in front. Okay, so you're actually looking for a number in it. So here, dealing with 1, state the degree and leading coefficient. So here, my degree would be 4. My lead coefficient is going to be 7. All right? Okay, so for number 2, this is not one variable. All right, because you have 3xy and 2y squared. So that one doesn't work, not one variable. For 3, this doesn't work because you have a variable in the denominator. Variable in the denominator means that it is not a polynomial in one variable. These two are fine, but that x in the denominator means that you cannot do that. All right, so find the following values given the polynomial functions. So here, what happens if I put in b squared for x? Okay, well, let's look. So I have 2b squared squared plus 3 times b squared minus 1. So this becomes 2b to the 4th plus 3b squared minus 1. There's my answer. Number 5, what happens if I do this and this to g? Well, a couple things will happen. Seriously, first off, I'm going to put c plus 2 squared minus 4. Then on the outside of that whole thing, that's where I'm going to put this 2. I'm taking 2 times the function of g, where c plus 2 is replacing x. So when I multiply this, c plus 2 squared is actually going to be c squared plus 4c plus 4 minus 4. All right. How do I do that? You know, a lot of kids will put c plus 2 squared, and I will get c squared plus 4. That is wrong. Draw your box if you have to. You know, c plus 2, c plus 2, c squared, 2c, 2c, 4. There's that middle term that I've got to deal with. So now when I put this together, I get c squared plus 4c. That cancels out. So now I take my 2 through 2c squared plus 8c. There's my answer. So graphing of a polynomial function. Take a moment here. You know, if my degree is 0, that's a line. You know, if my degree is 1, that's x, that's your linear function. Quadratic we've talked about. But now notice, cubic, quartic, quintic, as I go on, please notice something. If it's an odd degree, the ends go in different directions. So if I look at 3, this end goes down, this end goes up. Even degree, go up, or it's going to go down, all right? So count the number of times it changes directions, okay? So it's going to go up, stop, change direction, down, change direction, go up again. Notice it crosses 3 times. That means that that's going to be a degree of 3. So now, end behavior of a polynomial. What happens to the function as I go towards negative infinity? So that would be left. What happens to the function as I go towards positive infinity, which is going to be right? So when I look, here's kind of what I'm looking at. So my degree is even. I know this because my end behavior, they're both going the same direction. My domain is all reals, my range is all reals, okay? Greater than this minimum, so greater than 0, 0, all right? As it's odd, they're going in opposite directions, okay? Domain, remember, is your limit on x and y, and range is your limit on y, so you're looking at what can happen here. So this is all the information you need to tell me about given on a graph, all right? So if I'm looking here, you know, as it goes left, what happens? As it goes right, what happens? What are my limits on x? What are my limit on y's? How do I know the leading coefficient is negative? Well, it's opening down, and that's kind of what I'm looking at. So when I look, so end behavior, you know, as x approaches infinity, the function does what? Well, this function goes down, so it's going to go towards negative infinity. As x approaches negative infinity, means going left, f of x is going to be negative, okay? So you can go back and look, so it's going to be negative and negative. So it's even. I know that because both ends go the same direction, all right, and there's going to be 2 real solutions. How do I know that? Because it crosses the x-axis exactly twice, okay? So, end behavior, odd or even, polynomial function, and state the number of the real zeros. So if I come in here in the middle, number 7, first off, it's going to be even. I know that because the ends both go the same direction. As for my end behavior, you know, as x approaches infinity, the function is positive. As x goes towards negative infinity, not negative 8, negative infinity, so left and right, so as it goes left, f of x is going to be positive. And then any real zeros, well, none, because it never crosses the x-axis. All right, so for number 8, so this one's going to be odd. I know that because this one goes this way, this one goes this way. All right, I know that end behavior, you know, as x goes towards infinity, as x goes this way, the function is positive. As x goes towards negative infinity, f of x is going to be negative. Then I count 1, 2, 3, 4, 5 solutions, or 5 zeros. There's my answer. All right, so we're not really doing a whole lot of work, we're doing a lot more describing. So take a look, come talk to me with questions, have a good day.